All right, good morning, everybody, and thank you so much for joining us on today's webinar. Today, we will be focusing on an introduction to the Illinois EPA Office of Energy's Public Water Infrastructure Energy Efficiency Program. We're so excited to have you all joining us today, and we're excited to talk about both the program and some opportunities for water treatment facilities to increase their energy efficiency. Again, this program is brought to you by the Illinois EPA Office of Energy. We will have CEUs available today, so those that are interested in CEUs, I will send a follow-up email, and please just let me know if you're interested in a course number or a certificate for CEUs or professional development hours or credits. We are still waiting for that course number from Illinois EPA, but we've always gotten a course number, so never fear, we'll send that out when it is available. If you have questions on today's webinar, please either use the Q&A box that's located at the bottom of your screen or the chat function. I will be posting things in the chat thread today, and I will keep in touch with you about your questions. So we will address all questions at the end of today's session. So thank you again for joining us. We look forward to having you learn about the program, and we hope that after this event, you'd be interested in joining us in an energy assessment. So now I'm going to pass it over to my colleague, Sean Maurer. He's a senior energy engineer at CDAC, Smart Energy Design Assistance Center at the University of Illinois, to launch today's session. Thanks, Sean.
All right. Thank you, Cassie. Appreciate the introduction. We did have one person comment there was no sound. If I could just get a quick check. Can everyone hear us okay? Okay, looks like we got a few saying yes there. All right, great. Well, hopefully the person who's having sound issues, we can get that figured out and let you know that you can hear us. All right, so today I want to talk a little bit about the water assessment program through the Public Water Infrastructure Program that the Illinois EPA Energy Office hosts with us. We work in partnership with the Energy Office as well as the Illinois Sustainable Technology Center to offer these no-cost energy assessments. This program has been running for about 5 years for wastewater facilities. This is our 5th program year. And last year we ran a pilot for water treatment facilities to see, if there were significant savings available out there in the market, what kind of things we could look for. And that was a very successful first run for the program. And so now we've opened it up to water treatment facilities as well as wastewater facilities. So again, it's a no-cost energy assessment as long as you're a publicly owned treatment facility in the state of Illinois. Similar assessments are running somewhere around $6,000 to $12,000. And our program is filling fast. We've had a lot of interest this year as people are coming out of the COVID lockdown and stuff. They're looking for projects and support. So if you're interested in an assessment, please get in touch with us as soon as possible and we'll get you onto the list. We offer a comprehensive report where we list the cost of upgrades, some economic analysis for those upgrades, energy savings potential, and any applicable incentives and funding opportunities for those projects. We really try to help you out with implementation as well as just identifying the sources of energy efficiency. So first steps in applying for the program is submitting the initial application. It can be found on our website at smartenergy.illinois.edu. Your facility must be located in the state of Illinois. Yeah, you're going to have to agree to allow CDAC or ISTC out onto your site, look through your facility and identify efficiency opportunities. Be willing to share facility information. Key things we're looking for there are the previous 2 years of utility information so that we can identify energy trends. A year or 2 years of your most recent monthly operating reports. That way we can compare flow rates to your electric consumption, see if we can identify any trends in your usage that link back to your actual process. And then we'll also be gathering detailed information on motor and pump sizing, equipment that's in operation at the facility, hours of operation, things like that. Next, you have to be willing to share your final assessment report with the Illinois EPA Energy Office. This is not a regulatory report or anything like that. It's not being used for that. But the office does want to gather this information and then track implementation in the future just to see the effectiveness of the program and how it's working. So we do have to agree to share that report with the EPA Energy Office. And as I noted before, you have to be publicly owned. If you're a privately operated one, if you're owned by like American Water, one of those private corporations, um, then our services aren't a no service fee for you, but we can assist you on a contractual basis. So once we've got that initial application in, then we start that data collection process. We'll work with you over the phone, gather some initial information about the equipment at your facility, operations that you have, so we have an idea of what we're going to see when we come out for the site visit. We'll also start gathering that utility information and those monthly operating reports. And then once we've got all that information in, you'll be assigned with an engineer at our office and we'll schedule the site visit. So what you be expecting once that all gets scheduled and the site visit is set up, the project leader is going to contact you and schedule a site visit sometime within a month or so after you get your application turned in. And then once that site visit happens, we'll go over the details of what we'll be doing during that site visit here in a couple of slides. But about a week after that site visit, we try to return to you a short list of the potential measures that we're looking at for your facility. That way you can look through that list, see what we're looking at. If there's anything on there that you've already looked at and you've determined isn't cost effective for you or you're just not interested in, you can tell us to remove that from the list. And if there's anything we left off that you want us to look into, let us know. And that way we tune the report for what you're wanting to see and you get what you want out of the assessment. Once you've got that short list back to us and it's approved, then we'll start working on the report. And it usually takes somewhere between 6 to 8 weeks to turn that report around, get it back to you for the final report. And then within a couple weeks after receiving that report, we'll give you a little bit of time to digest the recommendations in it. We'll reach out to you and see if you're planning on implementing any of those measures, if you have any questions about anything in the report, if there's any corrections that need to happen. Sometimes we may miss a detail or misunderstand something that needs to be clarified. And then we can update the report and get it back to you. And then if you're planning to implement, do you need any support? Identifying funding opportunities, connecting with your local utility for incentives, anything like that. And then the IEPA Energy Office will also eventually follow up with you and check in about implementation plans and things. And again, they're just interested in what's the effectiveness of the energy program and how much assistance are we getting out to facilities. So what should you expect during the site visit itself? The first thing we usually do when we come out is a pre-assessment meeting. So we'll meet with you in person, or we can also do these site visits during a remote visit if you're more comfortable with a remote visit due to the COVID situation now. In that pre-assessment meeting, we'll go over initial benchmarking for your facility. So we'll look at what your energy use intensity in terms of kilowatt hours per million gallons processed and how that compares with some of the state and national averages, just to kind of give you an idea of what the savings potential is for your facility. And then we'll also discuss with you any known equipment issues, desired upgrades, and process details to help us clarify what we're looking at before we start digging into the actual walkthrough of the facility. Once we've concluded that pre-assessment meeting, then we're going to go through the actual assessment. We're going to walk through, we're going to have cameras with us. We're going to be taking a lot of pictures of motor nameplates, equipment settings. If you've got a SCADA system, we're probably going to go through the various screens of the SCADA system and see what kind of controls you have available to you. Usually we like to walk through your process following the process flow from raw water influent all the way to finished water output. And we're going to be asking a lot of questions as we go through, trying to identify savings opportunities, things that you've looked at the facility, the way things work. And what we're doing there is just trying to identify if there's any process improvements that can happen, any equipment upgrades that we can look into. And again, trying to identify what your desire is as far as upgrades and potential projects to look at for your facility. And then we'll wrap up that process. And again, we'll go back to our office, generate that short list and turn that back to you and then start working on the report. So some common questions that you might want to look forward to us asking on that site visit. One of the big ones is, do you know your distribution pressure and the leakage rate in your system? The average water loss rate for the US is about 16% in distribution systems. Um, in Illinois, and particularly in economically disadvantaged communities that have limited resources to do major upgrade projects, that can be up to 30% or more of your distribution leakage losses. Um, so we'll be looking at, if your operating pressure is particularly high, we see this a lot in communities that have large elevation shifts. The lower elevations tend to have higher pressures. Is there a way to look at reducing that pressure? And that will thus reduce how much leakage goes out of that distribution system. We'll also be looking at the operation of pumps and motors on the system. Are they doing some kind of on-off control? Or do you have VFDs to help smooth that flow out? And again, we're looking at a couple of things there. Smoothing out that flow saves energy and reduces wear and tear on those motors. And if you have on and off operation of those pump motors, you get slugs of water moving through the system, you get pressure transients, and those can exacerbate or create new leaks in the system, particularly at pipe bends and things. So using a variable frequency drive on those motors can help reduce those pressure transients, and again, extend the life of your distribution system and reduce the potential of exacerbating any existing leaks. We're also going to be looking at, for filtration systems, what kind of backwash control do you have? If you're doing a manual backwash control, is that based on just flow rate through the filters? Is it based on a timed sequence? Kind of what's convenient to the staff to do? Do you have some kind of automation of that backwash system? And again, what we're looking at there is minimizing how much wastewater is coming out of the plant, maximizing how much throughput you have, so that minimizes your initial raw water pumping. And again, that ties back into, if you're minimizing how much water you have to pump, you're also saving how much energy you're going to be spending on pumping that water. And then we're going to be looking at, are there any equipment issues that are causing additional water loss in the facility? We recently ran to a facility that the control valves on their filters were leaking a little bit, and that was causing about half the filters to just dump water continuously down the storm wastewater drain. And so identifying those as an issue and figuring out funding opportunities and a quick method to repair that issue and reduce that water loss is going to be a big benefit for that facility. So just an example of what the assessment report looks like. That front cover page is going to have a picture of your facility and some basic contact information, when the site assessment happens, so you can track that in the future. And then one of the first things we touch on in the executive summary is, what's your energy benchmark? So the first table you see at the top there is that kind of energy benchmarking comparison. We pull the national averages for either a groundwater facility or a surface water facility, as those have distinctly different benchmarking metrics. And then we also pull the Illinois averages for those. And we're looking specifically at your electric consumption per million gallons of flow. And then right after that, you're going to see a summary table of the measures that we've looked at for your facility. It's going to detail your energy savings, your cost savings, the capital cost of those measures, and the appropriate economics. Usually we're looking at simple payback, before and after incentives, and what the incentive amount that we've identified for that measure will be. A couple of things you might want to think about into why you might want to conduct an assessment with us. Preventing and reducing rate hikes. If you can improve your facility's energy efficiency, especially for growing communities, that can limit future rate hikes for expansion projects, covering the cost of that. You're also reducing just the entrained cost of energy for moving water through the facility, particularly if we identify leaks that can be repaired. We're also going to identify process improvements, might help improve the quality of the water that your facility is producing. And again, primary focus is on that energy efficiency. How many kBTUs per gallon of water are you moving through that facility? We're also going to decrease the impact of future utility rate increases. Utility rates are only going to go up over time. And so if you're reducing your energy now, you're going to reduce that impact later in the future. We can also use the reports to prioritize process and equipment improvements. If you're looking now to do kind of a budgetary process for facility upgrades, our reports can help identify which ones are most cost effective. Um, maybe you can do those up front and then bookmark those savings and tie them into larger projects in the future. We can be used to help convince committee members or student council, or sorry, city councils to invest in certain projects. Maybe it's a large cost project, but it has a good payback. Then these reports can be used for that kind of assistance for that budgetary process. And then you can also use this report to advertise to your community that you're an efficient facility or interested in sustainability. It's a big thing for a lot of communities now, is to show their citizens that they are responsible stewards of the environment. So here, this is just a close-up view of the benchmarking your facility. This is probably one of the more important parts of the report. We put a lot of resources into understanding the benchmarks for processing water. There's a lot of things that impact what the benchmarks are, where the source of the raw water is, whether it's groundwater or surface water. The size of your facility has an impact on the benchmark. Larger facilities can take advantage of economies of scale more so than smaller facilities. And so we did a lot of research, pulled a lot of information together. One of the main things why the Illinois average is a little bit higher than the national average, part of that is economics for the state of Illinois compared to the national economics. The state of Illinois has a lot of communities that have limited financial resources. And so what we're looking at in the state of Illinois is I think the state's average was somewhere around 23% as far as the leakage rate in the distribution system. That higher leakage rate also translates to a higher energy cost per million gallons. And so part of this is nationally, you're looking at there's a lot of influence for surface water where plants are pulling from seawater services and doing desalination, where most of Illinois' water is coming from ground aquifers. Pulling that water up through the ground is a little bit more energy intensive than pulling it off of a surface water source. And the other thing we're looking at there is just that economic impact. There's a lot of areas in Illinois that are struggling with economic resources. And so there's a lot of facilities that have older aging equipment that drives up that energy intensity. And there's a lot of facilities that are manually operated. They don't have access to automated controls and SCADA systems that can help reduce that energy intensity for their facilities. The next thing we're going to be looking at in that report, we'll get into a detailed analysis of your utility energy consumption. You'll see a couple of different charts in that energy analysis, utility analysis section of the report. We're going to be comparing your plant flow to your electric usage, either in a scatter plot or a bar chart, depending how clear the correlation is between those. But what we're looking for is there a strong correlation between plant flow rates and your energy consumption? Usually we're going to see that if you've got VFDs on your systems and your plant's process can adjust pumping rates, chemical dosing rates, things like that, to match the demand on your distribution system. If the correlation there isn't very strong, we know we're going to find a lot of energy savings opportunities on pumping and process control. The other thing we're going to be looking at is if your facility is using natural gas for heating. We'll do a quick analysis on that. Usually that correlation is pretty strong, ties to weather. So that's what you're seeing on that chart there. It's a comparison of gas consumption to heating degree days. And this kind of gives us an idea of how well insulated your building is what kind of impact and efficiency your HVAC systems have on your overall energy consumption. Um, and so what we're looking for here again is just kind of a general high level overview of the potential for energy savings for your facility. And we'll call these out in descriptions of these charts in your report. So what are some common treatment measures that we've run across as we've been looking at facilities? Last year we had 6 pilot facilities that we were looking through for opportunities. And as we move forward, what kind of opportunities are we going to see at other facilities? Probably the biggest thing for potable water plants is pump VFD opportunities. There are a lot of plants in the Illinois that are running pumps in an on-off lead lag control system. So adding VFDs to those not only is going to save energy, but you've got maintenance savings from reducing cycle times on those pumps. The number of starts has a major impact on the longevity of that equipment, and also has an impact on leakage rates for your system, reducing those transients and pressure. We'll also be looking at demand management, both at energy demand management at your facility and water demand management in your community. We've run across a number of communities that have some pretty good demand management policies that we'll touch on here in a minute. And we'll also be looking at, again, using VFDs, process improvements. Can you shift things around at facilities in order to decrease that peak electric draw that you have at your facility? We'll also be looking at process optimization. Primarily, this focuses around filtration and optimizing that process to minimize how much wastewater you're producing. Facility optimization goes to lighting, HVAC improvements, building envelope improvements, insulation and air sealing, replacing kind of aged windows, anything like that. And then we'll be looking at energy recovery options. And we'll touch on a couple of those here towards the end of the presentation. So touching on pumping VFDs, as I've noted, most utilities have some incentive for non-HVAC VFDs based around a custom incentive process. So Ameren, Illinois has an 18-cent per kilowatt hour incentive for public sector facilities to do customized projects. And in ComEd, that's 12 cents per kilowatt hour for those projects. If you happen to be on a municipal electric service or a co-op, we will contact them and try to figure out if there are incentives for you. And we'll integrate those into the report so that you know what's available. Usually what we find for VFDs is that they are cost effective for motors. 7.5 to 10 horsepower tends to be kind of that lower range, running more than 2,000 hours per year. What we find a lot with water facilities is that those pumps have a high head pressure because you're pushing out to water towers. And so they tend to be limited in how much they can slow down based on the head pressure that the system requires. But even in those applications where you've got limited turn down, we find that many times VFDs are still a cost-effective option for facilities. And so we'll look at that for your report and we'll analyze that potential for you. It's usually one of the measures that we include in almost every report. Looking at demand management, on the plant side, we're looking at shifting peak loads to off-peak times, whether that's shifting pumping runtime so that you're filling a storage reservoir when you're at a low demand period, and then letting your pumps kind of run at an average speed even during high demand because you've got that storage on site or at some kind of storage reservoir. We'll also be looking at reducing motor size where possible. Most plants are designed for a 20-year outlook where they've projected community growth. And if that isn't realized in a community, now you've got a facility that's oversized for the demand that it sees. And that has a big impact on your overall efficiency. And so a lot of times what we can do is look at what your flow profile is, kind of pulling from those monthly operating reports, compare that to what your design flow rates are for your pumps, and look at, maybe you could add a side stream pump that has a lower flow and handles those lower flow periods. We'll also look at one of the things that we've been researching is network metering for live tracking of um, process energy consumption, flow rates through the community. Um, and again, what we're looking for here is, can we identify leaks for you that can be addressed by looking at metering out in the community? And again, looking at process energy consumption in your facility to identify other places where this particular process is what's really driving peak load in your facility. Can we shift that to another time of day to minimize that peak draw? And then community demand management, looking at policies that you can implement with your community. Can you, for an example, we went to a community here locally that they had scheduled an irrigation period for their communities where odd numbered street numbers could irrigate in the morning, even numbered street numbers could irrigate in the afternoon. Once they implemented that policy, they saw their high service pumps reduce their run times from nearly 22 to 24 hours a day back down to 4 to 5 hours per day, just from that simple ordinance. And then the other thing we're going to be looking at is, just ideas to promote water conservation measures and technologies in your community, low flow fixtures, just kind of advertising to your community the benefits of limiting irrigation, pool fills, things like that, trying to spread those loads out through the day so that it helps your plant spread out your demand through the day. Looking at process optimization. One of the big things we've been looking at for a lot of facilities is what's your output pressure to your community. Typical distribution system design is somewhere between 40 and 50 psi in the distribution system, a minimum of 30 to 40 psi coming into residential structures and commercial buildings in the community. So if we're looking at a system and it has a small community that has an 80 psi distribution pressure, there might be an opportunity there to dial that pressure back, particularly at low demand periods of the day, saving again on pumping energy and demand and reducing leakage in that distribution system. Another thing for process optimization I've touched on already a lot is backwash control, mitigating how much water is wasted to the sewer. So what we look at a lot for backwash control is total suspended solids or conductivity metering that triggers, backwash starts are usually triggered on a flow basis or differential pressure across that filter. But then turning it back off is usually a fixed time. Using suspended solids or conductivity meter can shorten that backwash period and save, couple thousand gallons a day in backwash water flow. So it's one of the things that we've seen a lot in recommendations for water facilities, and we've actually seen going out the facilities that actual waste of water through manual control of backwash systems. And so that's one of the common measures that we've had for a lot of the plants that we've looked at so far. And then identifying and correcting leakage, transfer pipes within the facility, control valves, pump seals, things like that we'll call out in the report. Depending on the amount of leakage, we may tie that to an energy number in terms of how much pumping energy is involved with that leakage rate. If it's a minor thing, then we're just going to be kind of calling that out as something to address just for the longevity and things of the facility. One thing in particular to know, if you're in Ameren territory, they do have an additional incentive for water use reduction of 30 cents per 1,000 gallons that can be applied to these types of projects. So again, we'll include that incentive in your report if we find that a project can have a significant energy benefit and a significant reduction in water waste. Looking at facility optimization, one of the things we touch on here is high efficiency HVAC systems. There are air source heat pumps that can work below 0 degrees outdoor air temperature now and still maintain high efficiency without kicking on an electric backup heating source that's higher energy. And a lot of these facilities, you're sitting on groundwater. So a water source heat pump is a great way to heat your facilities. And we've seen a couple of facilities that have these in place already. And These are really, really useful where you've got a facility that has either a large groundwater storage tank on site you can tie in a heat loop to, and you've got that massive heat capacity there, or facilities that have a relatively constant flow of water through them. If you've got a smaller facility where you've got kind of on-off controls, the water flow isn't consistent through the facility, what we may look into there for you is the air source heat pump option instead. If you have gas equipment on site, then we'll be looking at potentially upgrading those to condensing gas systems. Again, just increasing that energy efficiency, minimizing your energy use for HVAC purposes. LED lighting upgrades are one very common measure. The reason being, they're pretty low cost, easy, quick to implement. The paybacks are fairly short. 3 to 5 years is very, very common for those. And it's a pretty significant amount of energy savings in general. And we also look at lighting controls like occupancy sensors, timer switches. For outdoor lighting, a lot of what we see is new fixtures, particularly LED fixtures that have been upgraded, have individual daylight sensors on them. And those daylight sensors tend to fail relatively quickly. And then the outdoor lights are on even in daylight. So looking at optimizing those to either a centralized daylight sensor, so you've only got one to maintain, or tying those to a time switch or a manual switch. So those lights are only on if someone's there at night, or if there's a safety reason to keep those lights on. And then HVAC controls, smart thermostats, optimizing dehumidification controls, making sure those are working properly. A lot of times we see kind of these standalone box dehumidifiers in plants. And the main issue with those is that humidistat sensor is right there at the unit where it's drying the air. So once you get, halfway across the room from that unit, it's not sensing that there might be higher humidity across the room. And so you can still have humidity issues. But there are plug-in remote humidistat sensors that can control those units that we recommend for some facilities where we notice those kind of humidification issues or dehumidification issues. And then something else is kind of a recent find that we've been digging into are energy recovery options for distribution systems and plants. Particularly at plants that have distribution systems that have large elevation changes, where they have to have pressure reduction for lower elevations so they don't have too high a pressure coming into the facilities. We typically see that there are pressure reducing valve stations, but there's a lot of energy tied up in that gravitational potential of that water. So out in Oregon, this kind of yellowish picture of a turbine in a pipe here, this was something that they put in a larger pipe in that facility. It's just a turbine that reduces that head pressure 1 to 5 psi per turbine. They tied a bunch of them in series and then tied those back into the grid. The pumps that are shown there in the top left, I'm not sure what the manufacturer is, but those are essentially, they call them reverse pumps, but it's essentially another type of turbine that's gives you a little bit higher head pressure drop than the helical turbine shown in that yellowish picture, and gives you a little bit more energy that you can tie back into the grid again. And then if you need to supply pumping or whatever, they can be reversed and used as a pump instead of a turbine. But for what we find for a lot of PRV vaults that are in remote locations, there are these smaller turbines that can be tied into these smaller water lines that they're usually tied to a battery system that powers the electrical components within that PRV vault. Usually some kind of lighting source. You might have a heater in there and a control panel for any kind of controls in that PRV station. And so again, these are just small turbines. They're tied to a motor. It's a great way to reduce the electric consumption of these small remote vaults that you have in your distribution system. And I believe the image sources there is listing where those top left pumps are from. Those are Soar Hydro pumps. But there are many companies that produce those. Last thing in the report, probably the one section that a lot of people are most interested in, is what money is available to you. So usually towards the end of the report, we have a whole section on, we'll detail the utility incentives that we found, put it in a brief table there so you can see what the incentive is for each measure, how it was estimated. We also get into any kind of customized incentive, how we estimated that custom incentive. That way it helps you later on when you go to apply for those incentives yourself. So we've touched on here already, the Ameren Illinois program and the ComEd Energy Efficiency program both have custom incentives of 12 cents per kilowatt hour. Ameren ups that to 18 cents per kilowatt hour for public sector incentives. And then Ameren also has instant incentives for air source heat pumps, LED lighting controls, heat pump water heaters. A lot of those recommendations that we have, they have an instant incentive program for where you contact a local contractor. The contractor does all the paperwork for you, and then you get the incentive. They come out, that incentive is applied to the final price of the installation of that piece of equipment. ComEd also has a similar instant incentives program that links to their lighting and things as well. The problem with those incentives usually is that I know for Ameren, the instant incentives aren't listed because they tend to shift a little bit depending on the contractor, the type of equipment being installed. So usually what we'll do just as an estimate for those in your report is we'll link back to the custom incentive if we don't know specifically what that instant incentive is. Just an indication here of the kind of territory we're covering so far. The blue icons are plants that we've received applications from and we're waiting for more detailed information. The little orange icons, yellowish colored icons, are plants that we have their information as far as a full application. We're just trying to gather some last little bits before we schedule the site visits or work with them for that purpose. And then the red icons are plants that we visited as either pilot plant facilities or plants that we've already visited this year and completed that site visit and sent the reports out to them. So as you can see, we're trying to cover the entirety of the state. If you see a little gap there that you might be in and we haven't been out to yet, help us fill that hole. We're very interested in seeing as much of the state as possible. So this is one, just a short example of, we went out to a surface water purification plant. On site, they had surface water raw pumping with the pumps were two-stage. They had a high and a low speed. They had an on-site filtration system. They also generated their own chemicals on site as far as chlorine dioxide and hypochlorite. So they had systems that were doing all that that was tied into the flow of the plant. But what they were doing at this particular facility is their raw water pumps, they would kick on at low speed in the morning as a warm-up, and then would ramp to high speed and run it at high speed all day, turning it off as necessary once they hit, they filled their water towers, their distribution system was full. And then they didn't turn on again until demand drew down to a certain set point. So what we looked at for this particular facility, they were on a local co-op, so incentive information wasn't available. We tried to reach out to the co-op and figure out what incentives were. We actually had a conference call between us and the plant and the utility, and the utility didn't have too many incentives to offer for them for these projects, but we're still working to figure out if there's some kind of incentive program to help them out with implementation. But you can see at the top of the report, the first four measures are kind of our quick payback incentives that we group into a package. For our report purposes, as long as that simple payback is less than 7 years, we're going to group that into a package and let you look at, if you package all of those types of measures together, what's the total impact that they're going to have on your facility. Projects that have a longer payback aren't necessarily projects that we're not recommending, but just due to that longer payback period, we're putting those into a consideration section of the report where you may want to look into those in the future. It may take a little bit more planning or looking for funding resources to implement those projects. So we're trying to give you those quick turnaround projects at the start and then your longer term considerations towards the end of the report. For this particular facility, we looked at that chemical generation, if they could offset that generation. That was a particularly large amount of energy. The hypochlorite generation had its own chiller system that would run. So that was a particularly high source of peak energy consumption. And again, kind of in the evenings, 5, 6 o'clock is when demand for water tends to pick up as people are coming home. They start cooking dinner, they're taking showers after work. And that's also when peak happens for a lot of power plants. And so looking at shifting this, storing that hypochlorite in a storage tank on site so that they could offset that generation was one of our recommendations. Upgrading to LEDs, they had T12 and T8 lighting at the facility. Looking at heat pumps for that plant, also looking at that for the chlorine dioxide hypochlorite systems. They have water coming from the raw water coming from the facility that they were heating or cooling as needed to hit an optimal temperature for those chemicals, but they were using an electric heater and then an AC unit. So we looked at, could you just lump those together as a heat pump system and save on that heating energy? And then looking again at, is there an option to keep those raw water pumps running at low speed instead of ramping up to high speed and then shutting them on and off through the day a couple of times as needed to meet demand? If they can slow that demand period down, run those pumps at lower speed, they're saving on cycling those pumps, those numbers of starts per year, gives them some maintenance savings as well as those energy savings. And then the longer term projects, we're adding insulation to the facility, increasing the efficiency of the actual plant itself as far as the building on site. They had existing HVAC systems that were electric heating and kind of 13 SEER AC units, looking at high efficiency units for those. And then we had an option for swapping out those dual speed pumps with variable speed pumps instead that had a longer payback period. So we went with the shorter payback period for that. This is a different plant. It's a groundwater purification plant. One of the big things we found for this particular facility, if you look at the top right corner there, was the average flow of the plant was about half the rated flow of the pumps, but they had on-off operation. So what you're not seeing here is we took the entire month of December. We had daily flows that we kind of averaged out on a per day basis to try to identify kind of when their peak flow periods were. What you can't see here is that, for the most part, these average flows for the month, you had a peak early in the morning, a peak at about 3 to 4 o'clock in the afternoon, and then a smaller peak later in the evening, about 7 to 8 o'clock. The other spikes and stuff are kind of intermittent, but there is this consistent, every night at midnight, there was a spike in energy consumption because the pumps would kick on at almost that exact time every night. And when you're looking at average consumption for a community, you expect it to shift a little bit day to day and kind of smooth that out on an average profile. But when you have a consistent spike over and over again, that's a good indication that there's leakage in the system, and then your system is kicking on to replace that leakage, and it's at a fairly constant rate. So looking at this, we identified that there was a need to address leakage in the system. We also identified that these high service pumps could have a secondary lower flow pump tied into that system that could reduce their energy consumption. We also looked at, they had outdoor lighting that, again, we noted during the site visit was on during the day. At this particular site, it's fenced in, it's totally enclosed, so they've got security there. We recommended a manual control for all lights except for a driveway light for security purposes that would be kept on a motion sensor. And we also looked at a VFD option for that high service pump. And again, what we're looking at here, the second and third rows of this chart, 2A and 2B, are both recommendations for that high service pump. One is that low flow pump that ended up being a slightly more cost-effective option, or slightly higher energy savings. The other option was to put in a VFD. It was a little more cost-effective, but because the energy savings itself was reduced, ended up being the secondary measure. They may decide at this facility to go with that option because it is more cost-effective. But we went, our focus is the energy conservation part, so that's what we recommended. Some other things we looked at, the facility had a lot of green space around it, so we recommended some solar generation. They already had a fairly low energy metric to start with, so that could push them to net zero. And the last thing to talk about in our reports, we do get into grants and loans that are offered by federal agencies and state agencies. We don't usually include these in our incentive calculations because they are so variable. We don't know what the amount you're going to receive is. But we do include information on how to apply for these loans. We include the EPA revolving loan funds, finance authority bonds. The Great Lakes Rural Community Assistance Program has assistance for figuring out rates. They also help with grant applications, things like that. USDA has some grant and loan programs. And we're also looking at now the new federal level Recovery Act grants and loans are also coming out. We're including those in our reports as well. So that's about everything I had to cover for the energy assessment process. If anyone has any questions, please drop them into that Q&A window for us. These slides will be available at our website after the event for anyone to look at. And again, if you're interested in an assessment, please feel free to reach out to us and let us know. We'll be happy to help you out.
Awesome. Thank you so much, Sean. I know you did a great job of answering some questions on the fly throughout our presentation too. But again, if anybody has any questions, please pop them in the chat. As Sean mentioned, we will share the recording of this session and the slides. So expect an email either later today or tomorrow with that information. Again, I'll put my email in the chat. Please email me if you're interested in a certificate or a CEU number when they are available. We will get those out to you as soon as possible. And then finally, yeah, if you're interested in an assessment, please feel free to email me or fill out our registration form online. We're excited to work with you and your plant to find energy savings and do some of those calculations. And even, another thing too is if, energy efficiency or an energy assessment isn't a good fit for your plant, but you're working on a specific project that may affect energy use at your facility or want to explore incentives, we can provide technical assistance too. So don't hesitate to reach out to us if you're working on an energy related project and needs support, either whether it can be developing an RFP, looking at incentives, thinking about different options, looking at the energy reduction potential for a technology. Let us know. We can certainly help just at the project level as well. Awesome. I see that there's a question in the chat. Do you conduct wire to water efficiency tests for large pumps very often? Sean, can you address that?
Yeah, we don't come out with electric meters and actually put them on the equipment. Most of us aren't certified to do that kind of testing. So what we're doing when we come out on site is usually kind of high level analysis for you. And then we'll recommend working with a specific engineering firm for those kind of specific tests.
Definitely. Awesome. Thank you. Sean, I had another question too. We talked about benchmarking earlier on in the presentation today. What are some good tips that you might have to maintain benchmarking over time, and why would it be good for a plant to benchmark their energy use over time, especially as they're doing energy related work?
Sure. We do run across a lot of times at plants that the facility operators don't know how much energy they're consuming. One of the things we try to do is coordinate initially to get our own benchmarking is coordinating between the plant to get the MRRs and the city clerk to get the bills. There are software applications out there that can help with tracking that kind of information. The city could either purchase that kind of software or track it themselves in a spreadsheet. But it does take some coordination between the city clerk and the operators at the plant to get that utility information and the water information in the same spot. Big things that benchmarking can help with, if you track back a couple of years, it can help identify anomalous usage that might indicate a problem with equipment or something like that. If your kind of energy intensity starts going up over time, it's an indication of some kind of process issue, wear and tear on the equipment, things like that, system leaks. So benchmarking can be really helpful for kind of tracking over time and identifying those anomalies that come up. So you get kind of an earlier awareness of any kind of issues at your facility.
Awesome. Thank you, Sean.
Mhm.
Another question I had, I know we talked a lot about the different types of kind of energy efficiency technologies, but if a plant is just kind of embarking on this process, what considerations or what sorts of technologies should they look at first for their plant? I know that every plant is going to be different and what they address, and
Sure, sure.
it's this kind of a broad question, but just curious on what plants should focus on first as they start their journey to energy efficiency at their facilities.
Well, for most potable water plants, pumping is the biggest energy consumer on site. So anything you can do that minimizes that pumping energy, be it VFDs, uh, pony pumps, that kind of smaller service pump that runs for low service periods, um, demand management in your community or on site. Um, those are three really good options for limiting that pump energy consumption, and a good place to start since that's probably going to be your largest energy consumer in most instances.
Awesome. Since we do have some wastewater folks on the call too, can you address what we've kind of found as some good tips for wastewater facilities as well?
Sure, sure. For wastewater, aeration tends to be the bigger energy consumer there. So, looking at optimizing aeration processes, either adding DO or ORP meters to your aeration process, high efficiency aerators, um, looking at your blower controls, and potentially blower upgrades are kind of the bigger projects for wastewater plants. Um, they're also a really good opportunity for water source heat pumps at wastewater plants too for building HVAC, and that can net some significant savings. And wastewater usually has a fairly consistent flow through them that smaller potable water plants might not have. So,
Awesome. Thank you. Again, another little moment to squeeze in any questions if you might have them. I did just want to mention too, since you're on this webinar today, you will be kept in the loop of upcoming events, different announcements from Illinois EPA Office of Energy, and upcoming opportunities for any funding that we hear of. So just to let you know, we'll keep in touch with you too about things that we hear in the field that we think might be most relevant to you and your plans. Looks like there are not any additional questions. Sean, is there anything else you'd like to address today on the webinar?
not off the top of my head.
I
Usually
know you've
respond
done
to
a
the
lot.
client's questions. It's
Awesome. Well, thank you so much, Sean, for all of your awesome information today about the Illinois Public Water or Illinois EPA Public Water Infrastructure Energy Assessment Program, but then also just about energy efficiency opportunities for water and wastewater plants. Again, the slides and the recordings will be sent out either later today or tomorrow, so please look for that in your email. If you're interested in CEUs, you can reply to that email or email me directly, and I'll get those to you when they're available. Finally, we do have an upcoming webinar on Tuesday, October 19th and Tuesday, October 26th. They're particularly more geared towards wastewater, but if you're interested for water treatment, you're more than welcome to attend. But we're going to be talking about aeration and energy and wastewater treatment. We have a session for activated sludge plants and a session for at lagoon plants. Again, CEUs will be available for those sessions as well. So thank you so much for attending today. We really look forward to working with you, whether it be an energy assessment or some technical assistance to help you move forward with your energy efficiency goals. Thank you again for attending, and I hope you have a great rest of your day. Take care.
yes.
Bye-bye.
Thank you all.